And here we go. So welcome everybody to this iteration of the Our Lady St. Louis group. We're going to be working with spatial data today. Oh, there we go. So the materials for tonight, I've posted them in the chat, but please put a link there if you need them again. The slides can be accessed here. Jose's repository is linked here. Making sure that you have R and R Studio on your computer, as well as the following packages. Ooh, there we go. So Our Ladies is a worldwide organization with the mission of promoting gender diversity in the art community. It was started in San Francisco in 2012 and now has about 216 chapters and more than 100,000 members globally. If you're interested in learning more about kind of the spread of the Our Ladies endeavor community, you can check out the ourladies.org for a shiny dashboard. So the Our Ladies St. Louis group was started in September 2017 by Janine Harris and Chelsea West. We've had kind of an increasing number of meetups over the years. And this year's organizers are myself, my name is Shelley Cooper, hello, Mary Painter, Janine Harris, and Crystal Lewis. So we are this year's organizers. I think this is our 7th of the year and we'll have one more. Hey, there we go. So last fall, we had 4 intro to our meetups for our first ever October extravaganza. In February, we had a Teach Me How to Google workshop. And in March, we had Creating Dynamic Reports with Shiny. And tonight, I'm really excited because we're going to talk about getting started with spatial data with Jose Feliciano. And our last one of the year, or I guess of the semester, will be on April 19th. We'll be doing an introduction to ARIMA, I think is how you say this, models, with Laura Rose. If you'd like to RSVP for more talks, we're gonna do that on meetup.com. We will be recording this talk, so feel free to turn off your cameras if you don't want to be recorded. Use the chat to ask questions. You can use it directly to everybody, or you can message the hosts directly as well. And then hopefully we can answer your questions. And if not, we'll give a shout out to Jose to be like, hey, we need some help here. Also, if you want your cameras turned off, totally fine. But in addition, you may want to keep yourself on mute just so like background noise doesn't become a problem. If you want to learn more or get involved, please visit ourladies.org to learn more about this mission and the global work. And you can also connect with us. We have a Gmail account, we have a Twitter, and you can view our previous Our Ladies workshops on our YouTube channel. And in addition, this talk will be recorded and posted to that YouTube channel as well. So we're really excited to have Jose Feliciano with us tonight. He's a data scientist with the USDA Innovation Center in Washington, D.C. He performs research under the Census Bureau's Social, Economic, and Housing Statistics Division, where he studies the impact of federal investments in rural America across racial and ethnic groups. Before USDA, he earned his master's in public health and biostatistics from the Yale School of Public Health and worked as a software engineer at Google and Facebook. So I'm going to stop sharing my screen and I'll let Jose take over. Please help give him a warm welcome.
Sweet. Hold on. It's been a while since I used Zoom. Hold on. Okay. Can anyone see my screen? I just want to make sure.
We can see your screen.
Sweet. Okay. Hello again. My name is Jose, and today we'll be talking about spatial data, and a big part of working with spatial data is getting, to work with different geographies, different levels, United States, and we'll be giving you some really good template on how to make map making, and I'll provide more comments. As everyone said, I work for the USDA Innovation Center, and I primarily just work with geospatial data. Some programs require, information at the census tract level, and often we have to merge a lot of data from like what's called the American Community Survey, which we'll be spending a lot of time. But I'm really excited to talk today to you. Hopefully you learn a thing or two. Here are some work goals, some workshop goals that I have. And I slightly modified my plan because I, actually just ended up, adding more stuff. But some of my goals is to really introduce you to various, boundaries that we work with. I think a lot of you have intuition what counties are, but there are a lot more geographic entities here in the US that we work with, such as tracts, block groups, blocked. We'll be talking about what's called zip code tabulation areas, which is not zip code, more about it later. Number two, as mentioned, I work for the Innovation Center under the rural development. So I'll be giving you some definition you can use to define, which area is rural based on some of the most commonly used definitions we work with across the US. Number three, we'll be using the Census Geocoding tools. So I'll give you some, background information about that. Number four, let's go over the 100 plus surveys that are conducted by the US Census Bureau. Number five, we'll be talking about the ACS data, which is really like where, there's so much data that are underutilized. So we'll go over some documentation and some tricks that you can do to really maximize working with this data. Number six, we're going to be working with some R packages, Census API. The one thing that I decided to add last minute is tidy census, but there's certain reasons that I'll expand later on. And again, we'll be working how to make static maps using ggplot2 and SF. I'll give you a minute or two, but the first thing you should do is you should go to this link. Maybe I'll type it in the chat, or I wonder if someone can do it for me, please. It should be like it should be very simple to sign up for a key. You only need to put in your organization name and then your email, and you should be getting an email within the next minute or two. The thing is, it might not work right away, but when you get an email, there should be a link that says activate it. You might not be able to activate it right away, but it should work, but you should really activate it at some point. Maybe tonight when we actually get to the part, but it should be a very fast process to get your key. We'll be working more about it later. And then the next thing that I think they provide you some of the links, but these are some of the tools we'll be using. Census XY, Census API, Tigris, dplyr, that's actually optional. And then ggplot2, and then tidy census. I think when I emailed them the packages, I think I also mentioned SF, but SF is typically downloaded or required by Tigris or tidy census. So you should do it, but I'll give you a minute or two. I'll just give you a minute and then I'll stay here for a while. All right. Maybe I'll just go ahead now again, and then I'll just give you more time later on when we get to the relevant part to make sure you have everything. But the key part here, I think the most important part is you signing up for an API key. So you can actually follow what I'm about to do at the second half of the presentation. All right, I'll go ahead. So let's go over some basics about working with census data. So typically when we're working spatial data, you do a lot of merging. And when you typically work with merging, especially with, you want your data to have like a key or an ID that you can easily like match things with. So, one of the standards we typically work with, there are things that are called GeoID, and these are typically numerical codes that identify, areas that we work with. Things, for each state, they have their own GeoID. Counties, they have their own GeoIDs. And, I mentioned it here, but having worked with a lot of really old data that are not geocoded, it can be a very nightmare. So it's nice to always have data sets that are, that have, this sort of ID or some standards that you can use to merge data sets. I think a lot of the data, I think a lot of state agencies are becoming better now, especially in light of COVID, but hopefully that continues. But typically a lot of state governments, when they post a lot of their data, whether for health, public health, a lot of times they don't include the, some IDs. So it's a bit nightmare to work with them. And here in the US, we primarily use what are called the Federal Information Processing Series, FIPS. And I think you'll see a lot of data sets, depending on the agency. Typically they're used, interchangeably. So some data sets you'll see GeoID, some instances you'll see them labeled as FIPS. There's actually an example that I'll go over later where, two agencies use different names, but they mean the same thing. And I already mentioned this earlier, but typically it's best to have FIPS code, which are spatial data, so they're easier to work with. Now we're talking about FIPS, right? Before we go over FIPS, it's probably a good idea to know how we break down spatial data and the different geographies that we work with. Obviously, there's the nation here. You can see the entire US. And there are things called, as you can see, zip code tabulation areas. Zip codes necessarily transcend different states. I think there are like 20 zip codes that crosses state lines. And then there are this thing called like core-based statistical areas that we'll be talking more about later on. But typically we think of, the federal government, right? The US, and then I think it's more, intuitively to what's the next level? States, right? Which state you are in. And then under that, typically there are counties, right? And then there are things called census tracts, block groups, and then census blocks. Typically, a lot of the data, unless you work with, let's say you're a federal agency that works with, tribals, that you might work with geographies that involves native lands. So that's like an instance where you might work with this. But typically a lot of research, we typically work with county, census tracts, block groups, census blocks. And then sometimes zip code tabulation areas. So these are, especially at my work at USDA, these are typical levels that I work with. This one is just a more visual representation of the hierarchy that are involved. Obviously, there's California. I think that's LA County. And then within that state, within that county, there's like a very unique tract within it. So this is like essentially this information, but in a more visual way. I've never actually worked with block centroid at all. I've typically just work maybe up to blocked, but this is typically like the hierarchy that we work with in terms of mapping and geographic information. So we just talked about the different hierarchies, right? The next thing they should probably learn is how we code things in a lot of the federal data sets or state data sets. So just an example, I got this from the census, took a screenshot of it. And typically each state are assigned a 2-digit GeoID or FIPS for that state. So here is an example, 48 for Texas, right? And then now if you go over the county row, right? Typically you combine counties within each state are normally assigned 3-digit numbers. And here as an example here, Harris County, 48 is the 2-digit that corresponds to that state. So 48 here, it means it's in Texas, and then 201 represents the 201 is how Harris County is specifically coded according to this federal standards. I've rarely worked with county subdivision, but here's the number of digits. Places, sometimes I maybe have only worked with places once, but I think the next important stuff, since we're going to be working with it in this data set, census tract, right? So again, census tracts are unique to each counties, right? So it follows the same logic. So here there's a 2-digit code for a state, 3-digit code for the county, and the 6-digit code for that tract. So ultimately, what you're really interested in, it's this 11-digit code. And the thing that you might ask now is, hey, why are you like belaboring this idea? Well, I think in a very nice world, you're gonna have data sets that they're going to have their geo ID, and then it's going to have, at that what level or state or whether or not it's a tract. But a lot of times, especially if you work directly with the Census API for the census, all you really get are digits and numbers and codes. And sometimes a lot of data sets that you get are not necessarily labeled the location. So there are data sets where you're only going to have the geo ID or FIPS, and then let's say statistics, like let's say percentage of people under the poverty line, right? And so if you see a data set that has a row for poverty line, that percentage, and then another one that's called geo ID, and it happens to have 11-digit. Well, 11-digit based on this table here, it's gonna have 11. So based on this, so if you see something that has 11-digit, most likely that's a geo ID that corresponds to tracts, census tracts. So that's really how you can tell. Obviously, there are 50 states, territories in the United States. Counties, there are roughly 3,000 counties here in the US. Census tracts, to the best of my knowledge, there are roughly 70,000 census tracts. And then I've never worked with census blocks, but for blocks, there are roughly 3 million census blocks here in the US. So I think like that's another way you can tell, looking at how like the number of rows that you have, that's typically how you can tell, just in case like, you're dealing with a data set that's pretty terse, that only has like 2 variables, or geo ID. Here, it's good to know, this is a list from the census, but these are the actual code in case you're working with data sets that are not labeled, right? So these are the FIP codes. So data set that has FIP code 01, it corresponds to Alabama. There are a lot of the territories with Virgin Islands. You can see American Samoa, Guam. They have their own FIPs. Definitely 72 Puerto Rico. But these are the code. I'm not sure if anyone has worked with this type of presentation, but if you want to save this document, if I provide like a CSV button, you should download a data set. You just have to rename it because I think the default is it tries to rename it with the presentation title. So, so if you were to open this one, you should have this data set that I just presented, just FYI. But here's like a reference that you can, like I said, this is like publicly available. So you can just like look up state FIPS in case you're working with data sets that are not labeled, that has only had codes. Now let's do like a quick detour. Like I said earlier, sometimes there are, data sets. I think I'm trying to belabor this. You should be very familiar with, looking at GeoID, and it should be an intuition what geographic level you work with. And one of the major data sets that are increasingly used in research, it's called the Social Vulnerability Index from the CDC. And this data set, it's available at the county and the tract level. And from the perspective of the CDC, right? So definitely if there's a pandemic or natural disaster, some places, some locations are definitely more prepared, right? And definitely some locations are definitely, some populations are definitely more vulnerable. And so they created this index from 0 to 1 in location that has 1 or closer to 1. Those are like the locations that are most vulnerable according to their metric. So how do they exactly create this index from 0 to 1? They actually use different variables from the ACS. So the latest data that they have for the SVI is for 2008, and they actually use the ACS data between 2014 and 2018. And if you look at these like variables to the right, this small variables, these are like the facets that they created. So technically, so besides creating like an overall social vulnerability index, right? They actually create like individual component scores. So social vulnerability index, I think I mentioned it here. It's typically called RPL teams. That's the overall index. But there should be also like an index between 0 to 1 for socioeconomic status. You can look up the documentation here, but I believe socioeconomic status is RPL 1. This is 2, 3, and 4. And the one that's called RPL with the S that's the overall social vulnerability. But these are the facets and different variables that they use. I think it's somewhat comprehensive. There's an argument that it could be better, but I think I definitely like it because it considers your access to like vehicle, for instance, your minority status, your age, your income, unemployment, poverty. So there's a lot of variables that goes into this data. So I'm just going to show you an example of this data set. So here, as you can see, just pretend there's nothing exists. Just pretend sometimes you might get a data set that might just have like FIPS and RPL teams. Well, I told you earlier, 5-digit refers to counties. So, the first thing they should have an intuition now is, hey, the FIPS or GeoID is 5 digits, so that's the data set for the county. And if this data here, state of revision, county are not available, then 25, you use one of the tables that I showed you earlier for the state. 25, aha, that's for Massachusetts. But this typically the RPL teams is actually at the very end of the data. It's a large data set from the CDC. But if just just highlight and click and just go all the way to the right, these are all the variables. If you want to see work with it, these are a lot of the variables that they include. But typically, if you're just really interested in RPL teams, you can always get a lot of these variables from the census directly. So I just want to give you, an idea on how things are coded. So now we've shown you at the county level, right? I mentioned earlier, this data set is available at the tract level. So remember one of the things that we talked about earlier, I mentioned this earlier, tract level data, it's 11 digits. So typically 2 for state, 3 for county, and 6 for tract. So now here's another data set, another partial data set for the social vulnerability. So these are the track codes, and these are the index set is from 0 to 1. If you get the nationwide data set, right, it actually compares it ranks essentially all the counties or tracts across the US. But another way that you can do it is, let's say, if you ask for the SPI for Missouri, then the score for Missouri, they're only ranking it within Missouri. So one of the maps that we'll be creating later will be actually mapping the social vulnerability index. So just FYI down the road. But yeah, I just want to show you how data are structured when you're working with geospatial data and geographic data from a lot of agencies. And now let's go to the next part. How do we define rural geographically in the US? There are a lot of, these are like the major rural definitions that we typically work with. So I think the biggest one that we work with, it's the definition from the OMB. Technically, it's the definition applies to what are called statistical areas. We'll talk more about it, but ultimately it goes down to the county level. We'll all talk more about it later on. And then the USDA, there's a data set called the Rural Urban Continuum Codes, and those are at the county level. And there's another data set from the USDA that's also used, I believe, HRSA, which is an agency under Health and Services, the health agency. I think they use RUC code for some of their health grants. So that one is actually for at the track level. There are a lot more others. So there's actually there are also like rural definition that census uses, but it actually doesn't fall. Like the geography doesn't really fall under traditional. It's like density based, so it's not really something that we typically work with. And also, census is very wishy-washy about their definition of rural. So technically, they always say, if you look into their website about how they define rural, right? They will always say, technically, they don't define rural. So they only define what's urban or what's metro. And what's not metro just happens to be rural. So it's like they always have this qualifier with how they define or not define rural, just FYI. Another data set that's actually, I think, developed by USDA as well, there's what's called the Frontier and Remote Area Codes, which is also at the zip code level. But I really don't recommend working with that because zip codes changes a lot, especially if you're working with older data. And another thing, I'll talk more about it, but there's a difference between postal zip codes and zip code tabulation area. I'll talk more about this later, but that's like one reason why I think like if you're working with zip code, what I would recommend is actually like working with a geographer or talking whether or not you have a good plan in case like you want your data to you want to make sure that you're using the same thing and not the different things. Those are not, those are two different things. I'll expand more about this later. But the one thing that I'll also say is the ROCA dataset. It's also available at the zip code level, but same thing, same warning. Zip code changes a lot here in the US. And more zip codes are always like added or created. So there's like a warning. So I personally don't like working with postal zip codes, and often if you have a geospatial capabilities, you probably, what you might want to do is for addresses that you have, you probably want to geocode it, get the like latitude and longitude, and then from there, use those latitude and longitude to assign it a zip code tabulation area. So that's what a lot of people do, but that's just, it's not really important, but I just want to mention it right now. Let's see. So let's go back to the OMB definition. I said earlier, OMB stands for the Office of Management and Budget. And typically OMB deals with another geographic level. It's called core-based statistical areas. But, and the way they define it, right? So the way they really define rural, according to OMB, areas that are not metropolitan statistical areas are rural, right? So just looking at this graph and how OMB works with this geography, if you can see the really like the really darker green, those are metropolitan areas. And those light greens are what are called micropolitan areas. Those are considered rural. And then areas that happen to be in counties that are not color coded, they're not part of statistical area. They're actually called like, they're non-core, they're non-core based areas. So they're not really part of anything. So again, the way the OMB defines is if you're not metropolitan, if you're not in a metropolitan area, you're rural. Here's a data set that actually comes from OMB. So these are what are called the core-based statistical areas. Those are what they call it, and and here how they classify it, whether or not it's a micropolitan area or metropolitan area. So this, as you can see here, it's a data set with just under 2,000 rows. So it implies that like roughly 1,100 counties are not represented here. Again, those are what are called non-core areas. And so, yeah, as you can see here, even OMB, this data set from the census, these two like columns are not even pasted together. So typically you want them to be, a 5-digit number. That's typically how we merge things. So this is not really a nice data set because first of all, you need to create a list of what's considered metropolitan areas and which county falls under those. And then you have to do a lot of programming. So I think to save you some time, I actually created this data set that has the 5-digit zip code or GeoID, and whether or not they're rural and not rural under OMB definition. And here I could have used 2019 or 2020. 2020 ACS just came out, I think a month ago. So these are the population for those counties. But I think this is a lot easier to work with, a lot cleaner. All you have to do is do a lot of like left merging or full merge using this data. So this is a more comprehensive list that you can work with. I'm really surprised this is not something that the census or OMB just publish. I'm not really sure why they're making it harder, but this is a data set that you get from the census and OMB. Here's like my clean version of rural. So if you're going to be doing research, county level research, and you want to identify rural versus non-rural, feel free to use this. It's provided for you. I also use this for my work. So feel free to use it. Here, let's talk about another definition. Now it's there's another variable that we use to identify what's rural and non-rural. And it's provided by an agency within USDA called ERS. I actually do a lot of research, collaborations with ERS. We do a lot of broadband work, studying the impact of broadband investments across the United States. And for this data set for rural definition, it goes beyond this binary clarification, whether or not rural or non-rural. One of the bad things about this is the last data set is from 2013, but the next data set should be out next year. So that's something to look forward to. Hopefully, they do more with this data set. But typically, the RUC codes, so what they do is they essentially use an older, so they use the OMB definition. Remember, it's rural and non-rural, right? And then they further break it down for counties that happen to be considered metropolitan counties. So they break it down by population size, and for rural counties, they further break it down by urbanization and adjacency to metropolitan areas. For the full documentation dataset, you can click this link right here. But like I said, they further break it down. So you have a score of rurality, and it's normally a score between 1 and 10. Like I said earlier, for metro counties, it's scored between 1 and 3, and it's broken down by population. So obviously, really large metro counties will have 1, and some of the smaller, less populated metro counties can have a score of 3. And then for the non-metro rural counties, it's broken down between a score of 4 to 9. And again, it's based on population and adjacency to metro area. So you have a score of rurality and urbanization. So this is something that you can work with. Again, this is for counties. Here, I just provided a data set. So here's like a data set if you just want to download it from here. But it's actually a very simple data set. It has FIP, it has state, the county name, the population for the 2010 census, and the RUC code between the 1 and 9. And then it actually has the description here. It's actually very nice to work with. So it provides you the RUC description as a column. So this is really nice to work with. Here, the third one that I'll be talking about, it's called RUCA. The RUCA codes, again, it's created by ERS within USDA. The data set is from 2010. And I haven't heard anything from ERS, whether or not they're going to create a newer version for this. But this rule definition, one of the key reasons why people use this is a big factor in assigning rurality, like a score of rurality is based on the daily commute. So I think that's why people, like I said, HRSA uses data set for some of their healthcare grants. The data is available at the tract and zip code level. Very technical methodology here. Personally, I've used RUCA, but I haven't really obsessively looked into documentation. But one warning, I'm going to mention it again. To the best of my knowledge, I think they use postal zip code here, which is kind of dangerous because postal zip code changes a lot. So I highly recommend, perhaps if you work with this, maybe stick with tract level, but not necessarily zip code level data. But it's the same idea here with the RUCA codes. Instead of 1 or 9, it's going to be between 1 to 10. And as you can see here, again, it's 1 to 3 are census tracts or zip codes that are considered metro and therefore non-rural. And then as you can see here from 4 to 10, right? It's based on population and whether or not it has like a high degree or low degree of commuting. So let's look at 8 or 9. 8 are small towns with high commuting. Number 9, it's also small town, but with low commuting. Number 10, there's also like 99, which is non-coded. I think there are a number of census tracts with 0 population. So that's one of the reasons why it might be coded as 99, or it's missing one of the variables that they use. So it's coded as 99. But if you want to use assign rurality based on commuting area, definitely use the record code from USDA. I mentioned this earlier, there are roughly 70,000 tracts. That's too large to append here. I don't want my slide to be really slow, but here's like a sample data from URS. So when I mentioned the code here earlier from 1 to 10, these are primary RUCA codes. As you can see here, look into documentation, but there are what are called secondary RUCA. So sometimes you'll see like 1.1. There's actually more details about it, but I have yet to see people use secondary RUCA. A lot of our studies that I'm involved with, we typically use RUCA, the primary one. So, but if for some reason you want to use secondary RUCA, it's more specific, then feel free to look into the documentation. But here's a sample data from RUCA. So, so those are definitions that we typically work with for rural. So let's talk about geocoding tools. You likely know which county you are in, especially if you follow politics, election year. You always talk about votes in those counties. However, you probably don't know which census tract or block you are in. Part of the reason, like census tract, it doesn't really have a fancy name. If you're in a county, you're in LA County, or let's say New Haven County, whereas census tract is just like census tract 11.001. So it's not very intuitive at all. It's not really important unless you work with addresses specifically. But luckily, Census has geocoding tools. You can use APIs, you can use the web interface. I think the benefit of that is I think GIS, a lot of my coworkers work for GIS. I think there's they have limited credit. So, I think there might be some cost associated for some of the geocoding tools. I think you can also use Google Maps, like a lot of Google Maps APIs, but the problem with Google Maps, if you look into the Google documentation, is a lot of the Google tools provide you free stuff up to a certain point. So you really have to be careful about, how many API requests they use. So if you don't want to risk having to pay, then definitely just work with the web interface or the API. So here, I'll just go over the web interface really quick to see how it looks. And here's the census geocoder. So let's say you might have some projects where you have the full address, right? But when you represent it in a map, you want to represent it as a dot. Therefore, you would need geocoordinates, right? So if you look at find location, one line address processing, if you want to use the web interface, so this one just uses the most current, doesn't really matter here. So let's say here, I'm just gonna type, let's say 65 Dwight Street, New Haven, Connecticut, 06510. And here, as you can see here, you can see the longitude, the x coordinates, and the latitude, which is the y coordinates. And then if you want to know which county, census tract, or census block you are, go to Find Geographies, One Line Address Processing. And then here, use the same. So let's say here, I'm going to be using 65, same address, 65 Dwight Street, New Haven, Connecticut. Just want to know for one thing. As you can see here, I think another thing to notice, I typed the wrong zip code and it actually corrected me. That's a big thing, especially when you're working with addresses, especially with user inputted addresses. So if you're working with those type of data, just be careful whether or not people have typed the right zip code. But as you can see here, it will tell you the GeoID, let's say for census tract. So GeoID for census tract. It's provided here. So you can see, just look for the geography here, tract or blocks, and look for GeoID, and that's what you really want. So that's how you want to, that's one way for you to know how things are coded for certain addresses. You know, there's also for congressional district, the GeoID, it's 4-digit. Counties, as you know, it's a 5-digit thing. So there's a lot more codes that are provided here. There's what are called like batch address processing. You can use the API, but one thing you can do is literally just like provide like a CSV file here, for instance, and no column, just like write the address in one line, street, the state. Sometimes you can also do, doesn't really matter if you include the zip code, but as you can see here, the only thing is it can exceed 10,000. So that's, if you do it here, it will provide you data, but I think don't do that if you're going to be working with multiple addresses. Let's go back to R, and this actually work with Census, this specific package. It's an API wrapper in R that allows you to work with the Census API, specifically the Geocoding API. And when I work with this, actually, like I just remembered, if you look into documentation in Census Geocoding API for this package, you'll see a lot of St. Louis reference in Missouri. And I actually looked it up, and apparently the author of this specific package is actually a professor at St. Louis University. I think Christopher Prenner, who's a sociologist. So just some Missouri connection, but he's the main author and who maintains this specific package. So let's go over some basic examples using R for this specific package. Here, if you haven't installed it, make sure you install it, Census XY. But once you have that installed, just obviously call library. That's how you call packages if you're new in R. And here, as you can see here, the function that you have to call if you want to get the specific coordinates, it's cxy_single, and you just put it in address format. You put the street, the city, the state or territory, and then if you have it, the zip code. I annotated here, but if you were to run this code right here, it will also work. Like I said, the zip code is not required, but if you have it, it tends to make things faster, a lot faster. So if you're going to be working with this package for multiple addresses, definitely try to include zip code if you're able to. If you want to call that, here's like an example output from the API. As you can see here, it will return you what's the match address, right? And you saw it earlier in the web interface, but if you put the wrong zip code, it will return one with the right one. So I happen to put the address of the White House correctly, so give it as is. And then, like I said here, the X coordinates is the longitude, and the coordinates for Y is the latitude. There's a lot of like other variables that it includes with. You're not really interested in these. These are not really relevant at all. It just breaks it down further by variables, but typically you'll get a data frame, and this is the data frame exactly that you would get. And then let's say, remember earlier, we got this coordinates, right, from the previous function call for the White House. Specifically, again, this is the longitude and the latitude, X, Y. And then if we were to call these, feel free to run this definitely in your R console. But if you were to run this, you would actually get a data frame with 164 columns or variables. So here, I just happened to include a partial output with all like things that are GeoID. So this like the variables with the GeoID are typically the ones you're interested in. So here, it gave me the GeoID for the state, for the this color area, we're not really interested. Counties, it's here. So you have all this information: congressional district, census block, tract, the legislative district. So that's like an example output. Like I said, this is only a partial output because typically you get 164 columns. Okay, so I think before I think we'll take a quick break. I think people want me to give people a break just in case, but let's just go over this really quick list. Maybe let's take a 5-minute break, but this like I provided a link that has all the 130 plus surveys that the US Bureau conduct each year. And let's just go over it. I'm going to open the link here specifically. And as you can see here, these are the description, the specific link. It has all the surveys and all the programs. It also mentions here that the largest one that they provide, it's the American Community Survey, and their business survey called the Quarterly Service Survey. And as you can see here, there's so many variables or surveys that they use, and there's so much data here. I'll be going over a couple of them after the break, but these are a lot of the data sets that are provided by the census, and there's probably a lot more. I didn't even know that, I think I just found it recently, they even have apparently Common Core. I know Common Core is a very controversial subject. I didn't even know that there's a survey involving Common Core. So I highly recommend, if you have time, especially, you know, if you want to know what data might be available for your research interests, there's so much information from the Census Bureau. And really take advantage of it. A lot of it are underutilized. And honestly, I primarily work with the ACS data, which is already a lot of information as is. So I highly recommend exploring these in your own time. But all right, so I think I'll be giving. Does anyone have any question? Right now, it's been background information, but does anyone have any question? If there are no questions, I'll give a break. Maybe be back at 8:03. Sorry, I think you're an hour ahead. You're an hour behind, so I think that would be 7:03 for people in Missouri. So see you back in 5 minutes.
Thanks so much, Jose. For right now, we're actually having a little bit of tech issues where I can't pause the recording, which is a little weird. Oh, yeah. But yeah, so everyone, you can feel free to like step out or back or whatever, but I would keep things muted and hidden just because I don't know how to do this. Isn't that fun? Perfect. Love it. All right. Thanks, guys.
For USDA. Oh. Hello again. Sorry, I think I just heard the recording started. I mentioned that before the recording just started that definitely spend some time to go over this list that I provided, a specific list. And definitely, I think you'll be seeing a lot more data sets provided by the census. The one thing that I know that my agency is providing, which I'm actually like the data representative, a lot of the broadband investment done by USDA. We're actually providing it to census. I still have to clean the data. They apparently want it in SAS format. So yeah, there's going to be definitely a lot more data that census. I think census is also spending a lot of money modernizing a lot of their platforms. So the one thing that actually just changed recently, so there's this data set that a lot of people in health policy uses. So it's called the small area health insurance estimates. And it actually just changed. I used this data probably more than a year ago, and it didn't even have this web interface. So before we go to the web interface, for instance, typically, if you just want to download like the raw data, these are very large data. It might say like 9.6 megabytes, but it's most likely going to be like 80 megabytes after you unzip it. But the problem with this data set, if you're going to be working with this, there's a lot of data cleaning that you have to do, a lot of filtering. So the one nice thing about this newly developed tool by the census, and census is definitely developing a lot more of these tools for different survey data. So let's actually go to that link. So the nice thing about it here is, so do you want the percent of uninsured or insured? And then do you want all states, all counties? So this web interface that they have for this specific data set, it actually like does a lot of the filtering for you. So when you get the data, it's a lot cleaner already. The only thing that you should watch out, I think I mentioned earlier, obviously the county FIPS, right? 5-digit. For SAHI, for instance, instead of providing you like a separate data set, right? If you look at here, if you look into the ID provided here, 01000, when it's 000, when you see something like that, it actually does not refer to a specific county. That's actually that's the entire number for that entire state. So depending on the data set that you work with, we need to watch out for those. But as you can see here, 01000, it's for the entire state of Alabama. So perhaps like you probably want to filter those out. If the name here is like the entire state, you probably want to remove those if you're going to be doing a county level analysis. But just something to watch out for if you're going to be working. But I like this web interface that they have here, and it even creates like a plot for you. So this is something that you want to work with. I think I was part of a study that studied access for breast cancer care. So one of the information that I got from here a year ago was the uninsured rate for females across the U.S. I just want to give you a quick overview of this. Another data set for people who are the economists here, I just want to quickly go over. There's this data set called the Longitudinal Employer Household Dynamics data sets. And these are like the main data sets that they work with. I listed them here. There's a job-to-job flow for job mobility stats. There's the thing called loads data set that breaks down employment numbers based on location, residence, workplace, down to census block levels. And I work with this data set, so I'll quickly go over it so you can see the type of amazing data that census has throughout the US. There are what are called post-secondary employment outcomes for statistics on earnings and outcomes for graduates of certain institution across the US. And I think this is the big one. I've never worked with it. I'm not an economist, but the quarterly workforce indicators. I think a lot of people definitely use that. I provided you the link for the data sets, but I'm just going to quickly go over the loads data sets. So you have an idea of what kind of data sets, crazy data sets that they have. I mentioned this earlier. They make the data available at the census block level, but let me just show you really quick. So for a lot of my collaborators, we don't work with census blocks because that's too detailed and too granular. And if you're going to be working with multi-year data, I mentioned earlier, there are roughly 3,000 blocks in the US. So if you're working with data for multiple years, it can be very overwhelming. So the first type of loads data set that they have is, I think it's, let me just show it to you, documentation for the odds origin that I compiled. These are not typically the way it's called. I just rename it for the purpose of this data set for mine. But if you can see here, there's a variable for year, state, where people work, the specific census tract, and where they live, which census tract, how many jobs for those different combinations. It also breaks it down by year, earning levels, and then which sector that they work with. And as you can see here in the sample data that I provided here, there's a person in this census tract, there's a number of jobs, who lives in this census tract, who happens to work in this census tract, and it breaks down the number. So I think it's really crazy idea that the census has this data about where people live and where people work and those different combinations. So that's like the odds origin data set. There are the other data set. It just breaks down the employment data based on, this one is based on the residents. So these are the number of people who live in this tract and the number of jobs of the residents there, what's their age, what's their salary group, which industry people are working in, which race, which education level, which gender. So I think like this definitely, if we're going to be studying employment data, I think this is definitely something that you might want to work with. And here's another version where the data set is provided based on where people work. So these are the job based on the number of jobs within this specific tract. And again, it's the same breakdown, but the WAC data set just breaks it down based on where people live. And the RAC just happened to break it down based on when people like live, residence area. So I just wanted to show you like how detailed some of the data sets are. And definitely for this one, as you can see here, there are the odds origin data set. This is really huge because like it lists out all the possible combinations of what people work and live. So these are really detailed data sets that the census provides. But this is not really the main point of presentation. I just want to show you what data sets are provided so you have an idea. So I talked about, the insurance, Asahi, and then the loads data set. But where the money is, it's really the ACS data. So let's actually go over ACS, and we'll be creating plots, graphs pretty soon. But the ACS data, it's an ongoing survey. It's a yearly survey. And according to the Census Bureau, they call it their premier source of detailed information and housing information about our nation. And it's really a lot of data about our nation. I think, a lot of the variables or data they can think of, they're likely there in the ACS. And even now, I'm still learning. Oh, this is still in the ACS, ACS data. I didn't know that. I'll be talking more about the variables, but there are typically two main versions that people use. There's the 1-year ACS and the 5-year ACS. So the estimates are based on for ACS 1-year estimates. So if people say 2009 1-year ACS data, those are data for areas with populations greater than 65,000. What people really use is the ACS 5 because it covers all areas regardless of the population size. And as the name implies, ACS 5 uses 5 years of data. So if people talked about what's the ACS, let's say poverty for 2019, they're actually referring to the past 5 years. So I think I mentioned it here below here. If someone talks about they're using a 5-year 2020 ACS data, they're actually referring to 2016 to 2020 5-year ACS. So it uses those 5 years of data to create statistics for that specific geography. I skipped this earlier, but for some of the older data, technically 3-year estimates also exist. I personally haven't used it. I've never really seen a purpose for me to use this data set. But I think the one thing they'll caution, I think the ACS 5 data, I think the first year it came out is 2009. Could be wrong, but I think that's the first year that the ACS 5, they first started doing it. But that's the basic introduction for ACS. And there are a lot of websites that talks about all the variables that are included, but there's only really one thing that you really need, and those are what are called table shells. And I'm really surprised, like people go to these like different websites, and the table shells, specifically, if you go to their website, if you go Google table shells, specifically for detailed tables, it's essentially a comprehensive list of all the variables that are included in the ACS data. And I said earlier, ACS data is a yearly collection. And so for each year, there's a yearly table shells. And I'm mentioning it now because if you're doing like a long-term study, a longitudinal study, 10-year study, and for that window, you're probably going to use two different ACS data. Let's say for that study, you probably want to check both tables that you're going to be using to make sure that the variables exist in both time frame, because it's possible that it might not exist. I've had that problem for one of the research that we've done. It didn't exist in older data. So that's one thing to consider if you're designing a study. And it's in my repo that I provided here. It's also the documentation. So for the repo, if you're not familiar with GitHub, if you click this, it should open. So this is like my repo, this is the link. If you press download here, it should download the documentation, the Excel into your computer. Another thing that I like, personally, I like to work with this specifically. There's this link they provided here. It's the API documentation. It also provides you all the variables, the tables, and in a similar like table-like manner. So you can just like search whatever variable that you want to work with. But let's spend some time working with the Excel. I think I have it open here, right? So typically when you, this is the ACS shell for 2019. As you can see here, there's table ID. You may think of, if you look here, table ID here, you may think of it as like more of like the concept, right? So here, this table ID, it's B01001. This is like the concept behind the table ID is sex by age. And similar approach, as you can see here, the concept here is sex by age, white alone, this table ID. But what you're really interested in, ultimately, when you're working with the API that we're about to work with and map, these are the variables that you really want to work with. So for instance, if you were to use this variable, right, it would get the total number of population within that area, total, it's not stratified. This variable here, the one that ends in 02, it will give you the number of males within that region or hierarchy. And then if you want the numbers broken down by age, look at how specific and granular the information. And I think I mentioned earlier, the ACS data, if you, let's just like browse. So the first thing you'll see, there's a lot of variables for age, for gender, origin. There's like breakdown by education, mobility. I work primarily a lot with broadband. So, so let's say if you want to search for like broadband, so if I'm looking at variables that might mention broadband, just search for it. But I think there are 70,000, 40,000 rows. Let's see how many variables there are. But if you just like go over from up and down, you can see there's a lot of variable. Labor force by internet subscription. The one thing that you should like note here, so if you look into the tables, right, when it starts like a new concept or table, column E here, it says 1 and 5. So that indicates that it's available. This variable is available in both ACS 1 and ACS 5. So that's really how you like read it. There might be some variables that's only available in ACS 5 or vice versa with 1. But these are all the variables that you need. And there's really a lot. I highly recommend going over this, but typically when a lot of federal agencies create their own data set, and typically a lot of those data sets are actually uses fully or in part the ACS data for a lot of those data. So definitely for the insurance data, the SAHI data sets that I mentioned earlier, I think it uses in the past decade, the ACS data to create those statistics. And as you can see, it goes very granular. So these are the type of information that are included in the ACS data. So it's really, and here, now it's voting age population. So it's really like a trove of information that people don't really use. And I hope you start using it more because of this presentation here. But that's a good documentation. Like I said, if you don't want to look at Excel, just literally look into the API. I tend to work with the API more. It might be a lot slower, but it's the same idea. Just do a search in your browser, and these are all the variables that are available to you. So the only thing that you'll really need to keep track is what variable you need and what the name they're going to be using. These are, if you see here, this information here is what we're going to be using to get the data using the API. So here's an example. So so let's say we want to do some research, right, on household internet access. It doesn't matter which variables, right? But for this argument's sake, suppose the variable that we want is this specific variable, B28002 underscore 0018. So obviously, here it tells you the state, the county for those data sets. This is the return, but let's actually go over the code. So the very first thing you should do is call the Census API package. So call the library here. So the next thing you need to do is you need to tell the package what is your API key, which is required. So the API key that you got from your email from the census, you just put it here between the quotation marks. And then it's very simple here. I'm saving the data as household data. I'm using get census function. And here, I'm telling it to use ACS5. I'm telling it to use 2019. So that means that in reality, right, I mentioned when someone talks about the 5-year 2019 ACS data, you have to look into the past 5 years, so 2015, 2016, 2017, 2018, 2019. So it's actually like 2015 to 2019 ACS data. And this is the variable that I want from my study. And here, region, I want the data in terms of county level data. So that's how you get the data directly into your R environment. It's very, very straightforward. And now let's go over what other versions or other calls that might want to do using the API. So here, as you can see here, I'm also working with the ACS5 2019. But in case you want 2 variables, like all you really have to do is for the vars argument, you feed it with a character vector with the characters, with the variables that you want based on, I said earlier, these are the variables that you want. So these are in column C using the table shells. These are the variables that you're going to be using for the API call. Definitely look into documentation for Census API, but here there's a lot of ways to filter things. So let's say I only want to do Connecticut only. Remember earlier, there might be some instances where you need to know the FIPS. So here, it's actually important to know. It happened to be that the FIPS code for Connecticut is 09. So when I use this API, I have to say, hey, region in, I only want the data where the state is 09. So this data will return county level data for those 2 variables for Connecticut only. And then here, I did one for tract level, and this one's specifically for Missouri. So if you were to look up the FIPS for Missouri, it's 29. And the only difference, as you can see here it's county and here's tract. It's very straightforward. In the case where you might want to use ACS1 instead of ACS5, all you really have to do is change the number from 5 to 1. So it's very straightforward. So that's how you work with getting census data. It's very straightforward. The key here is just like having this table shells that as a reference guide, and so you can see, so you know which specific coding, variable coding you need for a data call. Now let's start making maps. I think this is like for a lot of people who don't have any map making background. Here, I'm only providing like a very brief overview. I think this is like a good way of doing map making. I could bombard you for 2 hours with definition, what are shapefiles, what are projections. We're not really interested in those. I'm just gonna provide you like the default setting, how to create a nice looking one. But I highly recommend, if you really want to learn about map making in detail, definitely talk to a geographer and take formal courses about spatial rendering or statistics. So, you can literally have like an entire like semester course just on map making. But the big concept here is we need a shapefile, which is like a digital file or format, right, that can store the geographic location and all the attributes that we want to display. Here, it's very straightforward. Typically, you need, to download and upload shapefiles. But if you have the specific the Tigris package, it does all those things for you. very seamlessly. So you don't have to upload, download data. You just call the package, tell it how, which state or what level of geography you want, and it downloads the right information shapefile for you. Part two is you probably want to map very specific information. For example, I think I hinted this earlier, we're gonna map the SBI specific for Missouri. So that's gonna be the data that we want to merge to our map. Merging data, step three, we're gonna be merging our data, in the case of this example, the SBI data to the shapefile. I don't really want to overly define, because I could spend a lot of time defining things, and we just went over a lot of background information. But the data that Tigris gets for you, it's going to be of class SF and data frame, but it's also like a data frame class. So you can easily left merge things into that shapefile. So that's really what we're doing there. We're merging an external data to our shapefile, which happens to be a data frame. And then number four, we're going to be leveraging ggplot2 to render map. It's very straightforward, 4 steps, right? We'll map the SBI data specific for Missouri. I cleaned the data. I think in the example data that we went over for SBI, it's a lot of variables, but I cleaned it. If you want it, it's also in my repo here. There's going to be a variable called Missouri SBI CSV. So you just download it, from here. Or one thing you can do, if you don't want to download it from there, here's the entire data for Missouri for census tracts. So you can just download it and, make sure just rename it into something meaningful into your computer. Like I said, when you press this, it uses like the presentation name as like the variable name, but it's the correct data. You just have to rename it. So here, this is like the example data set that I download. This is the data set for Missouri. I mentioned this earlier, but typically when you download, let's say, the national data set for the social vulnerability index from the CDC, it compares all, let's say, counties or tracts across all states. But if you download a state-specific one from the website, it only compares it to, what's within that state. So the ranking between 0 and 1, it's exclusively uses information within that state. I mentioned this earlier. The thing that we're really interested in is the RPL teams, which is the overall, but it also creates like an index for those different facets that we went over. That's not really important, but I kept it. But again, the social vulnerability index is between 0 and 1, right? And locations that are closer to 1 are more vulnerable. So here's the data if you want to download it. But again, we're going to follow the formula that I prescribed earlier. So how do we create an SBI map for Missouri? The very first thing you need, it's obviously called the package. I just call it Tigris, might be Tigris, I'm not really sure, but I use it a lot. And here, for this specific example, you have to call the function called tracts. And here I'm specifying that I want the tract shapefile for Missouri, right? And here I name it Missouri shapefiles. And remember, the next thing I mentioned earlier is you want to load the Missouri SBI data into R here. I just happen to use R here. So here, I downloaded the CSV. The next line here, the reason why, if you do a lot of spatial data, this is like a big problem. So here, I'm calling it GeoID here because the shapefile. If you look into the shapefiles, let me just open R really quick, really briefly here. Here's my server. If you open is there a shapefile here? So let me actually open here and make it bigger here. So if I do, let's say, a head on this one, right? This is like the data that's embedded within that shapefile. And as you can see here, it's called GeoID. And if the reason why I am doing this next part here, well, it makes it easier if you're merging and the name of the variables are the same. But the main part here, as you can see here, is the as character. So here, the GeoID variable within the shapefile, it's of character type. And then when I read the CSV here, right, this variable here, it's actually numeric. So before you merge, you have to make sure that they're the same type. If like they have to be the same data types, either the same characters or they have to be both numeric. So here I'm creating a GeoID that's of character type. And even though I use dplyr here, for people who are not familiar with the tidyverse packages such as dplyr, I also included how to do it in base R. So here's, if you're more familiar with that, here's like code in base R. And then the third step here is you want to merge the SBI data to your shapefile. I mentioned this earlier. Let's actually just do it. So sorry about that. So if you want to know what class something is, you typically call class, right? And then whatever that variable here, as you can see here, it's SF and data frame. So so it can behave as a data frame, so we're merging it. So here, I'm merging it by GeoID here. Again, this uses dplyr, but if you are a base R kind of person, just replace left join with this code here and it should work. And the next part here is plot it, right? And I mentioned it earlier that the variable for the SBI variable is the RPL teams, right? So here, as you can see here, ggplot data. So here, when I merge the shapefile and the SBI data, I just created like another variable they called version2. So I'm feeding that data, and the next part is the next row is geom_sf, and as you can see here, just follow this same syntax, and it's going to render the RPL team. So feel free to run this code, but let me just go over what it would render. So in this next code here, this is like the code that I used to plot it, right? And this is going to be the output for that specific map. Well, it's nice, it did the job, right? But personally, I don't like the coordinates here, right? And if you're going to be creating ggplot plots using ggplot, I personally prefer without the ugly gray background. So one thing you can do is let's actually customize it. This presentation is not really a workshop for ggplot, but I just want to show you some codes that actually work and how you might go about it. So if you want to customize it, right, the next thing I did here is I actually added the team_void, which eliminated the gray background and the coordinates. So it looks actually like a lot neater. It's on a very conservative white background. So that's nice. But the one thing I really want to show you is you might not like it because it's blue on blue. If you want to make it more distinct, one way you can actually go over it, you can use the argument called scale fill gradient here, and you can specify the low and the high. If you're not familiar with color in R, these are like the hex numbers for those specific colors, but you can also in R, let's say, for low, you can just type, between the quotation mark white, for instance, and high, call it blue, it should work. But this is like one way I'm customizing it for my own preference. So I like this color better. Personally, here, the one thing I don't like about this, the default color, is like the darker one is the least vulnerable. I think for me, it makes more sense for me to make the darker color more vulnerable. It stands out more. So that's the reason why it's my own preference why I'm doing it this way. And then obviously, if you've never worked with ggplot, if you want to customize here, it's RPL team. It's not informative. So here, I'm labeling it as Missouri specific SVI. I think it looks a lot better than the default, definitely without the gray background and the grid. I think it looks a lot better. So here's like an example now. So if you follow this very recipe in creating maps, that's it. That's all you really have to do. Work with this specific package, call for the specific geography they want to work with. If you want to filter it by state, you can feed it with a state argument, and then work with upload the data that you want to merge, and then do a left join or merge depending on your programming skills. And then the next part is use ggplot2, the library, to create this plot. And it's very simple. And if you know this code right here, it will set you up for success. Now, I'm not really a big fan of over-explaining things, especially we just gone over a lot of descriptive information about geographies, but obviously, in this previous example, we use tracts, state, Missouri. I think for tracts, you actually have to specify the specific state if you're going to be going over tracts. But let's say other geographies that are available, let's say if you just want to state level, right? And then there's the county one. For the counties, you don't have to specify a state. So it's, without like a state equals something argument, it will get all the counties information throughout the US. But tracts and definitely blocks, it's going to require you to specify a specific state. But these aren't the ones that we typically work with: tract, state, counties. To the best of my knowledge, there are 40 to 50 shapefiles available. So there are like boundaries that are specific to native areas. And now there are things that are called zip code tabulation area boundaries as well. But I promised you earlier, I'm that I'm going to comment about the zip code tabulation area. So let me do that right now. So ACS data, and there are definitely geographies, right, for zip code tabulation area. Well, if we just look at people that, if we just like look at the variable description, right, zip code tabulation area, zip code, you might assume, okay, it's the same thing as the postal zip code that we use for our addresses. They're not the same. I think there are roughly 30,000 zip code tabulation area zip codes, and there are roughly 40,000 regular postal zip codes, and definitely more postal zip codes are being created. But most of the time, postal zip code is the same as the zip code tabulation area zip code. But a lot of the time, there are times when, let's say, zip codes that are primarily used for PO boxes, right, or zip codes that are in areas that are lightly populated, or if it's an area that's primarily commercial, then the zip code and the zip code tabulation area are not going to be like the same. Most likely that zip code, it's going to be mapped to a different zip code tabulation area. One organization that has like a cross file, like the UDS mapper, they actually create this data. So here's an example for New York. Here's the postal zip code, right? But the zip code tabulation areas, if you're going to be working with census data, right, you're going to be needing this to merge it with the census data. So here's an example where the zip code is different than the zip code tabulation areas. Like I said earlier, if we're going to be working with zip code data, I would definitely highly recommend talking to geographer or people who actually work with zip code data to make sure that you're mapping the right things and you're merging the right things, because I've definitely met people who attempted to merge people's address with zip code tabulation area information, and it's wrong. It's improper. So just be aware of that. So here's like a file that you can work with. Definitely keep the file. They're the only organization that I'm aware of that creates like this crosswalk. I'm surprised. Typically HUD has a lot of crosswalks, but to the best of my knowledge, only UDS Mapper creates this crosswalk file. Otherwise, you would need someone with spatial skills to do this conversion for you. So I guess one thing that you can do too, I believe, I'm not sure if, I'm not aware, maybe I'll look into, the dancers know. Like the one thing I was going to say is use the census geomapping tools, but I believe it doesn't provide information for zip code tabulation area, so it's not going to work. So you definitely need someone who has an expertise to do some mapping. If this is not enough, like I said, zip codes, there's always new zip codes that are being added. So even this might not be enough for your task. So just here's my warning. Yeah, when you're working with census data and zip codes. Now, let's talk about tidy census, right? And this is the thing that actually just added today. I was gonna cover another mapping tool, but I thought let's do this package, because the nice thing about this package specifically, if you're just gonna map an ACS related data, then it actually does a lot of things for you already. And it really eliminates like having to download like a shapefile and then downloading the ACS data separately, then having to merge. If you were to use tidy census properly, it does everything for you. And all you really have to do is use ggplot to render the map for you. So here, the task here that I provided here, the example that we're about to do, suppose we want to map the median number, the median percentage, right, of household income spent on rent. It's really big topic in politics, especially, talking about opportunity and income inequality, right? So I told you earlier, if there's a concept, most likely ACS has that data, and if you want the median percentage of household income spent on rent, then this is the variable that you would need. So that's like an example where if thought about it, I verified with the Excel file that I shared with you, and it happens to be there, so let's use it. Again, it's the same task. We're going to be mapping the state level median percentage of household income spent on rent. Here's an example code, library, tidy census. Here is different because we're using a different package, but here it's going to be Census API key, and then between the quotation mark, just paste your API key from your email. And here I'm just naming the shapefile with data. And then here you're going to be using the get_ACS function. And as you can see here, geography, state, variables here, this is the specific variable that I want. The year is 2019. The survey is ACS 5. And here, I mentioned it earlier, the default when you're working with a lot of packages is ACS 5. I just put it here just for demonstration purposes, for clarity. Obviously, if you want data for ACS 1, you're going to replace this number with ACS 1. The key part here, now pay close attention, right? So the geometry part here is true here, right? So what you're doing here is you're telling tidy census, right, that you just don't want the data as a data frame, you also want the shapefile. So by by setting geometry as true, what it's doing, it's getting the appropriate shapefile for you. So you don't have to merge. It's going to do everything for you. It's going to do the merging all at once if you specify that you want the geometry to be true. Another key part here that you should pay attention is the shift underscore geo. I set it as true. I think you might get some warning that they might discontinue this specific call, but typically when you're working with creating static maps that involve like Hawaii or like Puerto Rico or Alaska, right? They're far away. So when you create a map, right, it's gonna everything's gonna be zoomed out and everything's gonna be spaced out. So what this shift underscore geometry equals true does, it puts things together. So everything looks nicer. And sometimes, like depending on the tool that you use, sometimes it put like those states under the map, sometimes on the side. But let's just see like what it looks like. But those are the big points. So geometry true, the default is false. So if you want the data to go with the shapefile, you set this as true. And then if you're going to be mapping all states, including Alaska, Hawaii, or Puerto Rico, then set it as true. Here's like a sample code that you can run. And I'm not going to run it here. I already ran it, you're going to see. But the next part here, it's always good to see what data you're working with. So here, I have this variable called shapefile with data. So let me just go to my R here really quick, right? And then here, shapefile with data, right? So when I call that variable, as you can see here, it has like geometry, so it tells you it's a shapefile. The key part here is knowing what things are called. So here, GeoID, obviously those are the GeoID codes, so it's also the same GeoID. The thing to note here, it's the estimate here. So if we want to plot these percentages, we actually have to use the estimate variable. It's like this reason why I want to show this. And I showed this to you earlier with the when we plotted the SBI data. But if I call the class function with this specific variable, it will tell me it's both SF and data frame, right? So by just doing this, right, I eliminated the need of having to merge. So if you're just working with ACS data and you just want to plot that, then this is all you really need to do. So definitely take advantage of Tidy Census if you're going to be plotting a lot of ACS data here. So if you were to run this code, I could run it here, but this one runs it for me. So if I were to run this, right, it would create this specific map. So let me just highlight a few things here. So as you can see here, the color equals NA, right? Typically, it's not really needed here, but typically when you're working with county level data, the counties are squeezed together and there's a really like very thick gray border across states. So what happened is if you're working with county level information, it actually hides the color because of the gray border lines. So this is like one way, like even here, it's not really needed, but by having the color equals NA here, I actually eliminated those really ugly gray background or border between the states here. So it's not really needed here. It's more for like very granular geographies, but that's what color equals NA does. The other thing that I did here, for me, it's my personal preference. So typically, the legend would go here. But personally, a lot of the maps that I make, it's my own preference, but I think it just looks better for a national map to have the legend in the bottom. So here I move it by doing the plus sign, and then using this argument here. So I'm telling it, hey, I want the legend to be in the bottom. So I think that's my own personal preference, but feel free to remove it, obviously, but I'm just doing it the way I normally do it. But, I think this map makes sense, right? With your intuition, a lot of like California, I'm surprised about Florida. So I really thought people would spend less on their income as a percentage on rent, but obviously New England, darker. So definitely California. Not shocking, but yeah, that's really a very easy way to create maps. Like I said, if you're just going to be rendering ECS data, this is like all what you really have to do. And I think the next step for you, especially if you're not very familiar with ggplot2 or ggplot, it's really learn how to customize um, like these kind of plots. And you can definitely do a lot more. So let me show you what other things. So I think the goal of this presentation is to really um, give you some basic background, but the way you could, let me see if I have it here somewhere here. See if I have it here. So here's another map that I created. Sorry about that. Not sure why it's acting up, but there's actually a thing that I did for my final presentation. I did I took spatial statistics, and here I use like the Google Maps background. So that's one thing you can also do in the future if you want to learn more about it. Definitely, you can talk to me about it. Email me. And then here's another one. I use, again, Google Maps, and I track people's movements across the US. But there's a lot more things you can do in terms of spatial data. Remember, I told you earlier, it's really important to do the shift geometry equals true, because otherwise it would look weird. So if you didn't do the shift geometry equals true, this is what the map would look like. This is the way R would render it. So definitely make sure that you have this argument. This is the reason why we're doing this argument, to make sure that it looks like this image and not this, right? I guess I have like 3 more minutes. So I think that's like a good thing I eliminated some materials. But again, thank you for attending this workshop. What you should do next, definitely practice a lot of the thing that I did. Hopefully, I think my presentation material here is very clear. So just copy and paste it, make sure it runs. The thing that you should probably learn, if you're interested, what's like a good next step. So for a lot of studies, right, we typically do, there are like appropriate models for longitudinal data, right? Let's say AR1 models, for instance, but we almost never correct for spatial autocorrelation, right? So we always correct for temporal, for autocorrelation or serial correlation, depending on which field you're in, for the temporal aspect, but we never control for spatial. And definitely, if you're talking about house prices, right? And their allocations, house price will definitely impact the neighbors, right? So that's like an example where it might be a good idea to correct for the spatial autocorrelation. So you probably want to learn things that are called like SAR models. It's really just called like spatial autocorrelation, or autoregressive models. So there's a lot of things that, spatial statistics is really a really cool field, in my opinion. And often it really corrects a lot of biases. So that's definitely something that you should consider in the future. And then keep in touch. I really mean it. And if you see some error for some reason in my presentation slides, or if you need someone to talk to about any other projects, feel free to email me. Here's my personal email. But if you have any questions about any of the work that we do at USDA, that's my work email. Feel free to contact me. I mentioned earlier some of the work that we do. Um, and I'm starting to work more a lot about like the equity aspect of our broadband investment. So that's part of the work that I'm doing. So if you want to hear more about that, that's my work email. But I really mean it. If you have any questions about R, I love R. So, I'd be happy to talk to you if you have any questions, whether or not specific to spatial data or mapping, or otherwise, anything about R. So thank you. I know there's a lot of background information, but I tried to make sure you're equipped with knowledge to go further. Thank you.
Thank you so much, Jose. This was absolutely fantastic. Thank you so much.
Yeah,
Yay.
And I think you have a bunch of people thanking you in the chat as well. So, and some clapping going on and other things. So thank you so much. That was super informative. I didn't realize I'd actually make a map tonight, so.
And well, it's very simple. And what I don't like about a lot of the tutorials, they make it so complicated to make a map. Mm-hmm. And I think part of it is some of the tutorials out there, they don't understand ggplot. So they're doing it like a convoluted way. So I think like if you just follow like some of the recipes that are prescribed, it's so straightforward. And some of the people I work with who uses like SAS or like other software, I think I've convinced them to switch to R just for the mapping tools.
Fantastic.
Yeah.
Yeah. Well, yeah, thanks so much. And Jose has said he would be happy to connect with anybody, so feel free to do that. I'm going to stop the recording.